Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of November 3rd this time around. Tough moon week. Tough moon week. On that first night, the 3rd into the morning of the 4th, the moon's more than 95% full, and it's waxing. So that means it's got to get to full and then start to wane. And so we're going to have a lot of moon all week long. On that night of the 3rd into the morning of the 4th, the moon sits about 25 degrees northeast of Saturn. So you'll see bright Saturn about 25 degrees, about 2.5 fist widths at arm's length. Is Saturn sitting below the moon there. The moon's also 15 degrees. It's moving all night long, so these numbers are approximate, right? But it's also about 15 degrees to the southeast of Algol, the gamma star in the Great Square of Pegasus. That's the lower left corner star, the southeast corner star in the Great Square of Pegasus. The moon's maybe 15 degrees away from there. So you see this triangle of Saturn, Moon, Algol. From Algol, what you can do, even with this bright moon, the bright moon makes everything harder, okay? So what you might do, if you have a struggle with this, wait a night or two and let the moon clear out of this region a little bit more so it doesn't wash the sky out so much. I would say I would wait a night or two to come back. But you can use this as a guide. It's about 4 degrees below gamma Pegasi to get down to 34 Piscium. And so 34 Piscium is 4 degrees below there. It's a 5.5 magnitude star. If the moon weren't around, you might be able to see it with your naked eye. Pull it out with binoculars, but find it with your telescope. And it is a double star. So there are two stars there. 7.5 arc seconds separate them. So a little more separation than some of the stars that we've seen. But the brightness difference makes this a real struggle. 5.5 magnitude star and a 9.4 magnitude star. So I'm guessing you want a 4 or 6 inch scope. I've never tried it with a scope that small, but I'm guessing you want a 4 or 6 inch scope to try to pull these two stars apart. To see the pair of them there, or take a picture. Any telescope would show you this pair as a picture. One of the interesting things about this double star that we're seeing there is that we don't actually know whether they're a real pair in orbit around each other or not. One of the ways we determine whether we think two stars are associated in space, if we haven't seen the orbital motion, is to see if they're flying through space together. Or do they have the same proper motion, we say? Are they moving against the other stars in the same direction at the same speed? And these two stars do seem to share a proper motion, which suggests they're together in space. The likelihood of two random stars having the same speed in the same direction of motion across the sky is pretty small. But the way we measure distance to stars is as we orbit the sun, we measure the stars against the background stars from one side of the sun and from the other side of the sun, and we see them jump back and forth, parallax, trigonometric parallax we call that, and we see these things jump back and forth, and these things seem to show different parallax distances, different parallax angles, but those are very hard measurements to make. Even the proper motion measurements aren't trivial to make. So all of these measurements are hard, and they're conflicting right now as to say, are these together in space? Because if one of them has a smaller parallax angle, it's farther away in space. They're not an orbital pair. So hang on, we'll keep trying to find data on 34 Piscium to see if we can understand whether it's actually a binary or not. Eventually, we should be able to see it orbiting, right? If we watch this pair of stars over a long enough time, you should be able to see the orbital motion as well. But I don't think anybody's detected that. I haven't seen it if anybody has. So there you go. Remember, Saturn is near Neptune. It has been all fall, all summer, really. And so about 4 degrees northeast of Saturn lies Neptune. So get your binoculars, your telescope out, and take a look at that again. It's a good object for you to find. A little bit brighter, so you should be able to see it with the moon nearby. But again, wait a day and let the moon clear. By the time we get to the 7th and 8th, the moon will be 90% full. It will have waxed to full and will be fading back away from full, and it's near Elnath. We look at Elnath all the time. It's one of the stars in the horns of Taurus the Bull, in the top, the end star in the top row of stars from the V that marks the face and the horns of Taurus the Bull. But the moon goes by there every month, right? And there it is this month, sliding right by there. So we mark that passage often. So now, by the time we get to the end of the week, the last night we're talking about this week, Sunday night into Monday, the moon will have waned away to about 70% full. So still pretty full, still pretty bright, 2/3 full, right? And it'll be sitting near Castor and Pollux. So you got the Gemini stars, Castor and Pollux right here, and Jupiter sits right down below there. Who knows what that letter is that I wrote for Jupiter out there at the end. But you got Jupiter sitting there, and Castor's a little too close, a little too far away from Pollux, I think, in this rendering. But you've got Castor and Pollux and the moon sitting right down there in Jupiter. Now, when I see an arrangement like this, I think, Jupiter's going to go over here and line up, and we're going to get a nice alignment of Castor, Pollux, and Jupiter, as we saw. We've talked about this. We've looked at this some over the last year or so. But remember, as we catch up and pass the outer planets, they look like they slow down and stop and go back in the opposite direction. So they go into retrograde motion. Prograde motion, forward motion, is east against the background stars as I've drawn here, but every now and then we catch up and pass them, and we then see the planet go back into westward motion or retrograde motion, and Jupiter's just about to start that. By next week, the beginning of next week, Jupiter's in retrograde motion, so Jupiter really basically comes to a standstill this week, and if you start tracking it in the months ahead, watch it for the next 3 months, and you're going to see it move sharply back this direction instead of move over and form a line with Castor and Pollux like we saw sometime. I think it was just earlier this year that we saw that. And so this is all good stuff to watch. Be sure to check out Jupiter in the morning sky. It's up. By the time I start to see it at 4 o'clock in the morning now, it's well up in the sky. So this probably rises. I haven't seen it at night earlier, but it probably rises at 2 or actually no, it's earlier than that now. It's going to be rising at midnight or a little bit before midnight already. So Jupiter and Castor and Pollux are getting up there in the evening sky. So anyway, this is all good stuff. We got one more thing. I promised you last week, and I never remember the promises that I make, so it's hard for me to keep them. But I promised we'd talk about Algol. I drew a much better Perseus last week. Perseus has this sweep of stars that points up at the back of Cassiopeia into 2 strands of legs. The right leg, as we're looking at this here in this orientation, the brighter star, as you drop down there, the brightest star in the right leg is Algol, the demon star, the ghoul in Arabic. And so we got a 2.1 magnitude star, but every now and then, every few days, it drops to 3.4 magnitude. That's a big change. Remember, every magnitude is a factor of 2.5 in brightness. So this star gets 3 or 4 times fainter. As what happens, it's an eclipsing binary. As one star passes in front of the other star, you see the system get dimmer as you block the light from that background star. So when the brighter star gets blocked by the fainter star, you see a big dimming right here. These stars are so close together. When you see eclipsing binaries, you don't see them as 2 separate stars. They're so close together, it looks like one star, no matter what telescope we look at it with. But as they orbit, you block the light once in a while, periodically, every few days, and you get this drop. We're going to have one of these on November 4th and another one on November 7th. And I put my time up there, Central Standard Time in the United States. That's plus 6 hours. That's to get to Universal Time. So you can correct for the time wherever you are. But at 9:12 p.m. on Central Standard Time on November 4th, you're going to be at the bottom, the minimum of Algol, we call that, the minimum of this eclipse. It takes about 9 hours to track across there. So this is a project, right? If you want to watch this, this is easy. You can see this eclipse with your naked eye. That's how it was discovered. It's easy enough to see it dip that much, but you've got to be paying attention to watch what happens to it and check it every 10, 15, 20 minutes over the course of 4 or 5 hours. So you can watch it. You can start as soon as it gets dark on the 4th, and then you can watch it go all the way to eclipse and watch it come all the way out of eclipse, and you'll notice a dramatic change. What I might recommend doing is just taking a picture with your cell phone. This is a great cell phone opportunity to say every half an hour from 6 o'clock. Now that we're into standard time, it gets dark early here for us. And so now you can go out at 6 o'clock and every half an hour take a cell phone photo and then paste those together into a little movie and watch this Algol going into eclipse and coming out of eclipse. And I think it'll be pretty impressive for you. You want a better movie, a finer grain movie, go out every 15 minutes and do it. You get 4 of these measurements an hour over the course of 5 or 6 hours, and you get a little 25 frame film of Algol going into eclipse and coming out. Now it'll be an eclipse again on November 7th at 6 o'clock. It's at minimum at minimum light. So by the time it gets dark, probably 5 o'clock here now, it's starting to get dark, but it doesn't really get solidly dark until about that 6 o'clock. So it'll be here at the minimum. But over the next 4 hours, you can watch it come out of eclipse and get steadily brighter and brighter and brighter. So that's a good one to do on the 7th if you've got clear skies. Take your pictures every few minutes and do that. One last object for you. Great things. We got great things here. We got Algol in eclipse. We got Jupiter in retrograde motion. We got the moon and Saturn and Neptune and a fine double star, 34 Piscium. All of this stuff that holds up to bright moonlight very well. So we have a moon-filled week. We can actually see some of these things. But now we got one last thing we want to look at, and that is Algol, this lower left corner star, the southeast corner star in the Great Square of Pegasus, 2.5 degrees to the northwest of Algol is NGC 7814. So this is your challenge object of the week. You got yourself an 8-inch telescope. Go out and give this a shot. You got a 10 or 12-inch telescope, so much the better. And you got to do this. You got to do this the last 3 nights of the week, Friday night, Saturday night, Sunday night. Let the moon wane away a little bit and let it rise. So as soon as it gets dark, get outside and do this observation before the moon has a chance to rise up and wash the sky out. See if you can hop that 2.5 degrees, not much, up from Algol, and see if you can find in your 8-inch scope, 10-inch scope, 12-inch scope, you can find NGC 7814. It's this edge-on spiral galaxy, and spiral galaxies have a lot of dust and gas in the planes of the disks of those galaxies, and sometimes they have dark lanes of dust and gas right down the edge, and you can see that dark band, and this is one of those. So a photograph, if you've got a smart scope and you're taking pictures, a photograph's going to show that really nicely. You should be able to get some good images of this. If you start with low power on this object so you can find it and you can see it, and then start to crank it up, you might start to be able to see. I don't think you're going to see the dust lane with your naked eye, but you're going to be able to start to see the central bulge. You're going to see that it's not a perfectly thin disc all the way through, but it's got a bulge in the middle like that. You should be able to see that shape to it just a little bit. So give that a try. Check out NGC 7814. That's our galaxy of the week. Edge-on spiral galaxy, beautiful dark dust lane, all the other stuff going on that holds up to the moon. It should be a good week of observing. I'm looking forward to it. As always, thanks for watching, everyone, and we hope you have a great week ahead.